Circle theorems are wonderful because they provide us with clues on how to solve related circle geometric problems. Let's see how we can apply some theorems to tackle some exam type questions. For our first example, in the diagram, WXYZ is a circle with center O. If XY is equal to YZ and XOY is 61 degrees, find the value of C. Now looking carefully, we can see that triangles XOY and ZOY are congruent. This means they are equal. So we say that triangle XOY is equal to triangle ZOY. Now, since they are equal, it means that the angles in both triangles at O is also equal. Therefore, we say that angle ZOY is equal to angle XOY, which is equal to 61 degrees. Now, looking at the straight line WY, at the point O, we have two angles, WOZ and YOZ, which sum up to 180 degrees because the angle on a straight line is equal to 180 degrees. Therefore, we can say that angle ZOW will be equal to 180 minus 61, which gives us 119 degrees. Now again, since we are told that the center of the circle is O, it means that lines OW and OZ are equal because they are both radii in the circle. So we have that line OW is equal to line OZ. What this means is that triangle WOZ is an isosceles triangle. And remember that the base angles of an isosceles triangle are equal. Therefore, in triangle WOZ, the angle at W is equal to the angle at Z. So all we have to do to find C, which is the angle at W, is to subtract 119 from 180 and then divide it by 2. Now, we are subtracting from 180 because the sum of angles in a triangle is 180. So we have 180 minus 119 divided by 2. In this case, we are dividing by 2 because both angles are equal. So this gives us 61 divided by 2, which is equal to 30.5 degrees. So the value of C is 30.5. Now let's take another example. In the diagram, O is the center of the circle WXYZ. Find the value of the angle marked C. Now, this is going to be a very simple and straightforward one. If you recall the theorem that states that the angle subtended at the center of a circle is twice the angle subtended at any other point on the circumference. So, we can see that C is an angle subtended at the circumference, while at the center of that circle, we have 240. This means that 240 degrees is twice angle C. So to get the value of C, we are simply going to divide 240 by 2, and this gives us 120 degrees as the value of C. Now to our last example. In the diagram, O is the center of the circle WXY. WY is the diameter and XWY is 42 degrees. Find WYX. Now, again, you need to recall that the angle subtended on the circumference of a circle by a diameter is always a right angle. So what this means is that angle WXY is equal to 90 degrees. Now again recall that the sum of angles in a triangle is 180 degrees. Therefore, in the triangle WXY, if we add the angle at W, the angle at X, and the angle at Y, we should have 180 degrees. This means that we have 42 plus 90 plus the angle at Y is angle WYX, which is 180 degrees. Now let's add. So we have 132 plus angle WYX, which is 180 degrees. And when we collect like terms, we have angle WYX to be equal to 180 minus 132. And this gives us 48 degrees as our final answer. And that is how to apply the circle theorems. If you want more, join me in another lesson.